I just found this super simple and funny method in the C standard library to obfuscate a memory area with the number 42. So this is a plain reference to the Hitchhiker's Guide to the Galaxy in the C standard library. So in this video, we're going to test that method and see whether we can obfuscate memory using it. And we're going to check out and play around with that function a bit. So the documentation says the memfrob, and frob stands for frobnicate. The memfrob function obfuscates the first n bytes of the memory area S by exclusive ORing each character with the number 42. So this is something that you could easily do yourself, but for some reason, which I don't know, this has been included in the C standard library. The effect can be reversed by using memfrob on the obfuscated memory area again. Note that this function is not a proper encryption routine, as the XOR constant is fixed and is suitable only for hiding strings. Yeah, really nice. Let's see how we can use it and if we can create a small project using it. And let's call the directory memfrob, and then let's cd into it and create a new file. And all that we need to do is, I think, include standard IO for the IO stuff, of course, and standard lib. No, do we need standard lib? I don't know. Let's not include standard lib for now. Let's just create a main method and print hello world to the console just to make sure it works, and then we can jump right in to the memfrob method. Let's save that as memfrob.c, and there we go. Now we have a C file, and let's go into the projects directory in the bottom right pane, just here below my webcam. And there we go into memfrob, and then here I will compile this using GCC, memfrob.c, and the output file is going to be memfrob. And we can execute that file directly, and we get the hello world output here. Perfect. Okay, so can we do something with memfrob already? What if I do memfrob hello, and I just pass a number, which is the expected size. Yeah, so we pass a memory area S, which is void. And the return value is also a void pointer. How does the interface work? I would expect we pass a memory area directly, so we pass some string. For example, constant character pointer, which is a string message, and the message is, let's say here's Daniel, just to make it unique. And then I will pass the message here, and then I decide in the second argument how many bytes of the memory I want to obfuscate. And I want to obfuscate all, of course. So let's use the string length method and call it on the message, and we can include the string length method using the string.h library. Okay, what happens if we compile that? I'm not too sure if it even works right now. Of course, there will be no output because we haven't even coded that, but let's just see what the warning message is. Warning: implicit declaration of function memfrob. Okay, that means it's not included. It's part of the C standard library, which is probably in standard lib. Let's try again. Okay, I can't find the method somehow. Here it says it's the C standard library, libc. C includes standard library. Standard library, standard lib.h. Do I have to link that using the -lc? Or what is the issue here? Implicit declaration of function memfrob? Maybe I am using the wrong argument type, because this right here is expecting a size t argument, which is the size, the length of the message. So message length. And the message length is, let's say 10. Let me just hard code that for now and just check if that resolves the issue. And if I compile now, I still get an error here. Warning, implicit declaration of function memfrob. Yeah, that means we are declaring that function, or we are calling that function, and it's not found anywhere. Maybe we have to cast the memory area to a void pointer, or to just to void. Void. Maybe a void pointer? No. Something is wrong either with me or with that method. Memfrob usage. The memfrob function encrypts the first n bytes, blah, blah, blah. And here a void pointer is being used. I have the following questions regarding the memfrob function. Why is the XORing done with number 42? The answer is simple. There's no reason. It's just 42. Is there any reason why XOR constant is fixed and why the designers of memfrob did not leave choice of the constant to the user? Well, and that's basically the entire joke of this video. It's a completely stupid method. At least if you want to do any serious obfuscation. In what sense is it suitable for hiding strings? Since it can be reversed and therefore shouldn't be used in applications where encryption is important, what is it used for on practice? The purpose of memfrob, if you want to call that a purpose, is to hide strings so you don't see them when you run strings. This might be useful when your binary contains plaintext passwords and you want to stop nosy people from finding out what these passwords are. Of course, it's not hard to crack XOR by 42, but it's better than nothing. Yeah, so that's the entire point of memfrob is to improve your password security, for example, your file security, your data security by a single inch. Yeah, but how do I use it now? I am using memfrob. Is there a typo here? No, memfrob. Oh, what's that? So I have this constant character pointer string, which I pass into here. I even cast it to a void pointer just to make sure it's compatible with the API. Then I'm using the size t argument. Something's not really adding up here. How to include memfrob. Standard IO. No, that's not it. So why is this method, oh my god, why is this method not Not being found. Is it not part of my C standard library? What if I do memfrob? So even the standard library finds the documentation for memfrob here. I mean the man pages find the documentation. Then let me just find out which header to include in C. To find out which header file to include in a C program, you should consult the documentation for the functions which I intend to use. Yes, I'm doing that. Memfrob 3. So which header file is this defined in? I know this is really basic for most of you. But I haven't done those details yet. The documentation will always specify which header file to include, like standard.io.h for printf and math.h for square root. Here in this example, string.h is imported. Is it coming from string.h? But if it is, then why isn't... No, this can't be coming from string.h because we're already including string.h and the method is still not being resolved. So, see, is there any command to find which header file needs to be included for a certain type or function? Well, I actually need it for a function, but maybe it's similar. For library functions, I use man function to find which header file I need to include. Yep. Is it coming from string.h? User include. So all the header files are inside user include. And that contains all the libraries I have installed. Oh yes, and there's also the SDL2, which I use for my graphics videos. There's C++ stuff, Clang, Node.js. Okay, if I grab -rli user include, let's cd into user include, and then grab -rli. Grab RLI is recursively searching all non-binary files. So it's searching text files. Anything binary, anything that is compiled is not being searched. So grab RLI is much faster than RL. And I want to search for memfrob. Let's see. And it's inside string.h. Okay. Let's vim into that. And then let's search for memfrob. And there it is. Frobnicate n bytes of s. And this interface, this prototype, this function prototype specifies the memfrob function expects a void pointer, so basically a pointer of an unspecified type, and a size t. So what is the issue here? Let me just open vim and let's open user include string.h in a separate window, and let's open memfrob here. And then let's go into the projects directory, memfrob. And Could the order of the include statements make a difference? What if I include string.h first? No, that's just a desperate try. So if I do gcc and I compile memfrob with the output file memfrob like this, it's not working. Implicit declaration. I don't get it. I really don't get it. It's right here. The function is right there. String.h. I include string.h. C include string.h. I can imagine that this function was taken out somehow. But no, this can't be the answer. I mean, I have to this can't be the answer. I have to maybe link no -ls. It is there. It's right here. So I have no explanation of what is going on. C include string.h. Cannot find implicit function declaration memfrob. If you're using the GCC compiler, don't use standard C89 or C99, rather use standard GNU89 or standard GNU99 as string character null, say GNU extension. Yeah, okay, but that is not the case for the memfrob thing. Or wait, there's GNU source, something GNU sourcey here. GCC compile GNU. What if I just attach this to the compiler statement? That doesn't do anything. Implicit declaration of... Is it maybe an issue that my C file is also called memfrob? I can imagine this is a problem. Okay. Move memfrob to main.c. Now we have a main.c file, and let's gcc compile that. No, still doesn't work. What if I move it and call it m.c? Move main.c m.c. gcc m.c. No, that's not it. You are using a function for which the compiler has not seen a declaration prototype yet. Well, of course, there is a prototype in string.h. Okay, it could be an issue with the include list. It's just the order of includes. Maybe I can throw out the standard lib. I can throw out the standard lib because that's what I don't need yet. Oh, but it can't depend on that order. That standard IO, it's just standard IO and string.h. No. Wait, what does the manual, the man page say again? Let's follow it very closely. Synopsis. Define GNU source include string h. Do I have to also write that? Define GNU source. I can't imagine that I have to write that. Oh, come on. Define GNU source. Define GNU source. Huh? And that seems to work? What is that even doing? So just because I wrote define GNU source before the include statement, I get a different error now. And it's not related to not finding the method. So we expected void pointer, but argument is of type constant character pointer. Yeah, so now we can do void. We can cast it to a void pointer and that should work. And now we don't even have an error message anymore. Why do I have to do this? Let's look that up. What is the meaning of GNU source? See feature test macros. Okay. Maybe there's a man page for those. Feature test macros. There is. Feature test macros allow the programmer to control the definitions that are exposed by system header files when a program is compiled. Let me just make that visible to you here. Okay, so again, feature test macros allow the programmer to control the definitions that are exposed by system header files when a program is compiled. That means that our Memfrob is not a regular method, it's a feature test method. It's a feature test macro. Yeah, it's a feature test method, And that is exposed by adding this macro, I think. So we define this macro, and if it is defined, then the implementation of Memfrob is exposed. That's my understanding right now. So, in order to be effective, a feature test macro must be defined before including any header files. This can be done either in the compilation command. So now it's better readable. This can be done either in the compilation command, ccd macro value. Okay, so we could also pass this flag to the compiler, and then then we can expect it to work. Or by defining the macro within the source code, which is what we are doing right now over here. So this is the macro. And it must be defined before including any header file exists, because header files may freely include one another. Thus, for example, in the following lines, defining the GNU source macro may have no effect because the header abch itself includes a XYZ. Yeah. In the following lines, defining the GNU source macro may have no effect. This line has no effect because the header abc itself includes XYZ. Okay, so what is a feature test macro? Some feature test macros are useful for creating portable applications by preventing non-standard definitions from being exposed. Other macros can be used to expose non-standard definitions that are not exposed by default. Basically, my understanding is that this memfrob function is so ridiculous, it's just used for experimenting and trying out stuff locally, but it should never be shipped as part of an application. And therefore, it's not really part of the standard library. It's part of the standard library, but it has to be explicitly activated by this experimental feature flag, by this feature test macro. So what happens if I Google feature test macro? What do the people on Stack Overflow write? Why do we need feature test macros? Imagine some company has written perfectly fine, super portable code roughly like the following. Blah, blah, blah. The program is completely fine and all is working fine, and the program is very C compatible. Thus should be portable to anywhere. Now imagine for a moment that X open source does not exist. What is X open source? A customer receives sources of that program and tries to compile and run it on his bleeding edge Unix computer with certified C compiler on a certified POSIX system, and he receives an error that the company has to fix and in turn has to pay for. I don't really understand the point that is being built up yet. This looks like a completely random name picked for a function is already taken in POSIX. When introducing new symbols that are not in reserved space, standards like POSIX can't just add them and expect the world not to protest. Conflicting definitions can and will and do break valid programs. To battle the issue, feature test macros were introduced. When a program does define something, it means that it's prepared for the POSIX standard and there are no conflicts between the code and symbols introduced by POSIX in that version. Feature test macros are not just my program wants to use these functions, it is most importantly my program has no conflicts with these functions. All right. Then in that case, let's continue over here and let's try to get the encrypted message. Or well, obfuscated message. And that does obviously not work because the man page says the following. Oh well, not the man page. The header, the prototype in the header says the return type is a void pointer. And we can't really work with void pointers, so we have to cast the return to constant character pointer. Okay, and now the obfuscated message can be printed to using printf. So we will print input clear text input, and then the string, and then a new line, and obfuscated input like so, and then a new line, and maybe just to align that we can put a tab here instead of a space after the colon. So let's do that. And now I think we are ready to try to compile that. And it doesn't work, of course, because I haven't appended the messages here. So first of all, we append the message, which is the clear text message, then the obfuscated message, and then we compile and execute, and we get a segmentation fault. Why? The message length is 10 and it should be above 10 here. So let's properly use string length on the message. Message length. And now all the lengths should actually be properly done. Let's execute all of that. Segmentation fault. Where is the segmentation fault coming from? It's probably in the printf statement. So let me just delete it. And no, it's not coming from that. It's before. It's coming from the obfuscation directly. We are passing as input the message, which is a string, and then the length of the string in bytes. No, in characters, but one character is a single byte. So what is the message length? %d message length. That needs to be printed to the console using ld because it's a long integer, and the message length is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is fine. So Memfrob is obfuscating the message, the full length of the message. What if I set as message length the value 0? Then it should obfuscate nothing. Yeah, and that is being done successfully. So the clear text input is here Daniel, the obfuscated input is here Daniel as well. That means the issue is with the message length. What if I do 2? That's already a segmentation fault. What if I do 20? Segmentation fault. So anything above 0 seems to result in a segmentation fault. Guys, I really expected this to be a very short video on just obfuscating a single string and that's it. Yeah. That's always what happens. But it's not really about, or those videos are not really about learning a single new function and then stashing it somewhere in our, or trashing it somewhere in the back of our brains, but it's about the journey and the learning along the way. So far we learned about the man pages, we learned about how to find out where a function is included in the header files by just grabbing through the header files in user include. Then we learned about the feature test macros. Quite interesting. There's always a lot behind of all of that. But this message bug is still bugging me. The bug is bugging me. We provided a size t. Let's look up the documentation again, just to be sure we are understanding it correctly. Do I have to... No. Maybe my message length... No, the message length is correct because it's returning 12. If I add a single character, or 2 characters, then it should be 14. Yes, so that is working. It's not that method. It's in the size t. So the memfrob function encrypts the first n bytes of the memory area S by exclusive ORing each character with the number 42. We are providing it a pointer to a memory area. We're doing that here. Just to be very, very sure, we can also printf the pointer. Printf pointer address, maybe as hex value. Use %p for a pointer. Okay, so let's print the address using this pointer to message, and that is this message. Let's see what the output of that is. The pointer to the message is CB99008. Okay, looks reasonable. And whenever we execute the application, we get a new pointer. Which indicates, no, the pointer is even longer. It starts with 0x here. So, but we get a new pointer every time, which indicates that we are really putting things into memory properly. We are not having a zero pointer, a pointer with the value 0 or with something very low, such as 1 or even a -1 or whatever. Memfrob message. What if I cast the message to a void pointer? Does the pointer change? No, it shouldn't. It should be just a different format. Yeah, it's still the same pointer. So the first one is the pointer to the character pointer. Yeah, it's the character pointer, which is the string. The second one is the void pointer, which obviously has the same message. It's just a void pointer now. So we should be calling everything properly. The message that is being obfuscated The message that is being obfuscated has no reason to not be obfuscated. It has to do something with the size. But what? The message is the thing we printed above. The size is this message length. I can imagine that the string length doesn't return size t. Does it return size t? I don't know. Let's go to the string.h file and look up string length. And it returns size t. Returns the length of string. So that's not the problem. String length message. Pointer to message. Memfrob void cast and provide the message length. There's no reason for this to fail, honestly. Why do we have this segmentation fault? We have no segmentation fault, I think, if I remove that method. Let me just confirm. Of course, we don't have one. So it must be in the obfuscation. Or it's in the printf. No, it's not. Still, wait. Yeah, still seg fault. Void pointer message. Message length. And message is being printed. Is the message? The message should be fine. Printf. Message. Yeah, the message is just Hirsch Daniel. Constant character pointer. Memfrob void pointer. Don't think that space makes a difference. No. Message length. What if I remove all the... No. I don't want to remove the casts. No, because they don't make a difference, actually. Memfrob segmentation fault. Do I have to allocate the memory before I send it to Memfrob? Maybe Memfrob is trying to... Wait, do I need to allocate the memory first? Okay, I will do the following. I will do a proper memory allocation. cmalloc and calloc. Okay, I want to memory allocate the size of something. And for that I have to include standard lib as far as I know. Standard lib. Then let's open user include standard lib. And then let's look up malloc. And we memory allocate size t. So this is our message. This is the message length. Let's memory allocate message length. And then we get a void pointer to clear text memory, I think. Yes, that's a void pointer. The variable is unused currently, obviously. Let me just delete all the printf statements. Then we now have this memory available. Now we need to copy it. Now we need to copy the string into that memory. I know there's a function, memory copy n bytes of source to destination. Return pointer to byte s after the last written byte. So we now copy memcopy we will use memcopy. There's also string copy, but our memory is now a void pointer. Or we can also we can say that this is a character pointer and make this a character pointer. Then we can copy the string into this memory using stcopy, stp copy. What is stp copy? String copy. This is it. We copy from source to destination. The first input is the destination. The second one is the source. So let's use string copy. Destination is clear text memory and the source is the message. Okay, and now we should have, if we printf the new memory, we should be able to copy this. We should be able to read the string from the new written memory, from the allocated memory. Segmentation fault. Oh God. String copy destination source. String copy destination source. Clear text memory is a pointer and the message is also a pointer. This is not a constant character pointer, I forgot that. Maybe it makes a difference. But I don't know if it really makes a difference here. Now there is a warning. What happens if we compile it and execute it? Expected character restrict, but argument is of type constant character. Character pointer restrict. Let's look that up. You're passing in a character constant, which is equivalent to an integer, not a string for the second argument. But in our case, I'm not doing that. Or am I? Message, clear text memory, string copy, clear text memory, message. Of course, at the end of the code, we have to free the clear text memory, which we allocated. It's funny that I'm really struggling with every single method that I'm using in scope of this video. Clear text memory is a pointer. Message is a pointer. What does this mean? Passing argument 1 of string copy discards const qualifier from pointer target type. You say that the method takes a character pointer, but you're passing it a constant, no, a char const pointer. It means that you're passing a const argument to a function which takes a non-const argument, which is potentially bad for obvious reasons. Maybe because the clear text memory is something that changes because I write a new string into it. That might be it. So let's try with a character pointer. And then in string.h, string copy, yeah, the destination is a character pointer and the source is a constant character pointer. Okay. Then what happens if I execute that? Did I save? There's an issue with, of course, yeah. I have to delete that constant keyword as well, and now it should be fine. I think the string is being copied, at least I hope. No, we don't even get to that point because there's a segmentation fault. Again. The new memory is a string clear text memory. Why can't I print out the clear text memory? I want to allocate size of character multiplied by message length, but the size of the character is just 1. Yeah, but this time it works. Size of character. Wait, let me also print size of character is this, and then size of character. It should be just 1. Yeah, size of character is 1, so why did writing size of character before the message length as a factor, why did that change anything in the output? Let me try again without the size of. That's a segmentation fault, but if I write size of character, I get the string copy to succeed. malloc expect size t. Message length is also size t. I have no idea. At least the string is now in the new memory, which is good. And now we can finally try obfuscating it by passing, instead of the message, the clear text message with the message length. And maybe we also have to do the size of character here multiplied with the message length, as if it makes a difference. Clear text memory, of course. And now it works. And due to this obfuscation, the clear text input is #Daniel and the obfuscated input is this string right there. We can also reverse that. Let me just add another line here by adding double obfuscated input. And the result is a string. And then we insert as a last argument here the double obfuscated message. And this should show that obfuscating something twice results in the original string again. And the double obfuscated message is just, oops. Let's just copy the obfuscation code here and obfuscate this twice. Double obfuscated message, and then we obfuscate the, not the clear text memory, but we obfuscate the obfuscated message. Now I'm really confused. Now the text is always Daniel, there's no obfuscation. But that is probably because I'm overwriting memory somewhere. Yeah, of course, I have to do a separate printout after that. Otherwise I print the clear text, then I obfuscate, then I obfuscate again, and then everything is done in the same memory location, and therefore it's overwritten. So let's just change this to double or twice obfuscated input, and then we print out the double obfuscated message, which does not yet exist. Because we have to create it. So let's create it here. Double obfuscated message, and that comes from accessing the obfuscated message and obfuscating it again. And then in the printout, we of course want to print it and a new line is missing here as well. So let's clear the console, let's execute what we did, and there's our output. This is the final result of this video. Wait, let me clear again. Wait, just let me rearrange the windows and clear and execute. So why did this take so long? It's so simple. I did an obfuscation video before where it took like 10 minutes to code the entire obfuscation. But here we wanted to use this special funny Hitchhiker's Guide to the Galaxy method and ran against a rock wall of pointer hindrances. Okay. So we provide the clear text input, then we obfuscate it with 42 using this special Memfrob method, and then we obfuscate this string again, and as you can see, we get the same string again. So if you want to jumble up memory a bit for your local testing, you can use this method. It's quite fun if you get how to work with memory. We learned a lot in this video, and I hope you enjoyed this. And if you did, then stick around, and I will see you next time. Bye bye.